right, so this is part 2 of binomial expansion. So we've changed it now and we put some numbers in there. It's not just plain old x and y. So I already know it's a degree 5, and so we've plugged it in our calculator and it's given us our coefficient, just like from the previous video. And so we take our first term, just like before, and we put it in parentheses with a 5. So remember, this does not equal this. This is 32x to the 5th. This is just 2x to the 5th. So whatever your first term is, it must be in parentheses as you expand it. So that's the 4. That's a 3. Remember, we just descend these just like that until there's no more left. And then the same thing with the last. That would be 5. Let's do that in red. 5 to the 5th, and then 5 to the 4th, and then 5 cubed, and then 5 squared, and then 5. And if you remember, we always verify if it's a degree 5, there should be 1, 2, 3, 4, 5, 6. One more term than what was given. And then we simplify. So we're going to get 2 to the 5th, that's 32. X to the 5th, plus, and then we know this one's x to the 4th. And so it's going to be 25 times 16, which is 400, plus, and then that's 8 times 25 times 10. So 10 times 25 times 8. And you can see this is still tedious, but it's less tedious than doing it fully expanded. And it can be a little bit nerve-wracking as well. So I will show you a way to verify all your work and to check and make sure everything is correct. So this is 10 times 4 times 125, and you get 5,000. X squared, and then we know the next one's x, and then there's no x at the end. All right, so it's 5 times 2, which is 10, times 5 to the power of 4, and that's 6250. And then we just have one last one, that's 5 to the power of 5, which is 3125. So there we go. It's fully expanded now, but we want to make sure that everything is correct. So we are going to use our calculator. And so I've already put 0, 1, 2, 3 up there. Remember, when we calculate our coefficients, our calculator plugs in 0, 1, 2, 3, 4 all the way across. So it's giving us those numbers. And so if you look at each one, they make a nice little formula that we can plug in our calculator, and it looks like this. So n is our degree, right? If it's a degree n, that's our n across. So our degree here is 5. So if you think about it, this would be 5 comma x when we plug it in. That's how we plugged it in. So x is not what we're thinking about here. What we're thinking about this is the first coefficient. Our first coefficient is 2. That was our 2 that we plugged in. And then we need to give an exponent. So you see your exponent goes from 5 to 4 to 3 to 2 to 1 and so on. So that's what this is up here. That is our actual degree for this one. So it's 5 minus, and then like I said, the alpha is x. And so if you think about it, our first alpha is 0. So that would be 5 choose 0 and 5 take away 0. That's going to give us our first term. Now the last one is a 5. And you notice it is alpha. And so what we're doing is saying alpha equals x in the calc. Okay? And so that would then be x. So if I plug this into my calculator for the y value, it will spit out all my coefficients. Like this. So we go math, and then scroll to probability number 3. And then we do 5 and x. And then parenthesis 2, exponent 5 minus x, and then 5 exponent x. And so this is each of our terms. So if you think about it, we're plugging in 0. If I plug in 0, that would be 5 choose 0. That would be 5 minus 0, so 5. And then that would just be 0, so there isn't one. So now when I go to my table, look at my coefficients. 32, 400, 2,000, 5,000, 6250, and 3125. So it'll give you all the coefficients, and then all you have to go back is descend that x. But that is our expanded one. So let's try another one, both the same way. I'm going to do it by hand first, and then expand it. All right. So our first term here is 2x, and our second is 3y. Now there is a minus in the middle, so you can't just say 3y, we have to say negative 3y. So let's plug in our calculator to see what our degree 4 gives us. Let's clear this out of here. Math, probability, number 3, and so it's 4, choose x, and again, make sure your table set is at 0 and 1, and table, so it's 1, 4, 6, 4, 1, so 1, 4, 6, 4, 1, and use the whole paper. It works really well. All right, our first term is 2x, so we're going to do that one in green. That's our 2x. So it would be 2x, 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 and again, we start with 4, 3, 2, 1. And then our last term now is negative 3y, and so that would be 4, 3, 2, 1. All right, and we don't put the 1. And so now that we have so much going on here, what we're going to do is expand separate. So this is 2 to the 4th, x to the 4th, plus, and then this would be 4, 2 cubed, negative 3, and then we have x cubed y, plus 6, 2 squared, negative 3 squared. So I'm just expanding everything and separating it, x squared, y squared, plus 4, 2, negative 3 cubed, x, y cubed, and then plus negative 3 to the 4th, y to the 4th. And again, verify that there are 5 terms, so 1, 2, 3, 4, 5. You can also check one more thing, is your degree is 4, so the degree of each term would be 4. So 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4. So there's loads of patterns here. And now we just plug each one individually in. So 2 to the 4th, we know that one's 16. So 16x to the 4th. And then you notice with that negative here, we're going to be getting alternating terms. So this one is negative because there's only one negative. And then in the next one, it's negative squared, so that would stay positive. And then it's negative cubed, so it would get negative. And then it's negative even, which is positive. So you see the minus, plus, minus, plus. So once you see that 1 minus, you know you're going to get that alternating going. All right, so now we need to do 4 times 8 times 3. So 4 times 8 times 3. And then by doing the exponent with the negative, it allows us not to worry about the sign. So 96 x cubed y. And then now we'll do the next one. 6 times 4 times 9, which is 216. And then 4 times 2 times 3 cubed, 216. And then the last one's 3 to the 4th, which is 81. All right, and then we check in the calculator again. So this is again 4 comma x, and then our next coefficient was 2, and our last coefficient was negative 3. And so this would become 5 take away x, and this would become just plain old x. That's what we used before, right? So we change that to a 4, like that. And so there it is. So that's 5 comma x because it's degree 5, and we put 5 minus x and x. This is 4 comma x and 4 minus x and x. So if we plug this in our calculator for our y, it should spit out our coefficients perfectly for us. So y, clear that out of there. So math, why I cleared it, I don't know. We could have just left it, huh? 4x parenthesis 2 exponent 4 minus x. And the last one is negative 3 x. And you can see this makes sense. If I plug in 0, that's 4 choose 0. That's our first. So remember, this is 0, 1, 2, 3 as we move along. So it'd be 0 and 0 and 0, and that would give me degree 4 and nothing. And then it would be 1, 1, and 1. So that would become 3 and 1. It's going to give us everything we need. So second table, and there you go. See, it's 16, negative 16, 216, negative 216, and 81. All of our coefficients perfectly. And there you go. That's our binomial expansion. Thank you.